Okay, so I welcome each and every one of us to today's class once again, and I hope we are all preparing for this exam. By God's grace, with this program, like we've promised, your mathematics, your physics, your chemistry, and your biology would by His grace be covered, such that you will be able to enter into exam hall, and you'll be sure that yes, you will do well, and at the end of the day you'll be happy to see your results uh, by you coming out in flying colors. So today we are going to continue from where we stop, since we have stylishly wait for others to join us. So we're going to continue, and the replay for the class is going to be made available, so that whomsoever that would not start with us can easily go through it. And as we are going, we might be encountering some topics that you probably think you know before, or you have been taught before. Don't see it as unnecessary repetition. Pay attention to it like you've not heard of it before, because in most cases we tend to lose information when we assume that we already know it. So there's nothing waste, because that is what will probably happen as we are treating this syllabus. I get to understand. We're going to encounter a topic that you know very well. We're going to encounter a topic that you don't know, and so on like that. So don't lose interest in any of the topics. Pay maximum attention to them. I pray God will assist us. So I'm going to share my screen now, so that every individual can see. So please, can you see my screen now?
Yes, sir.
Oh, thank you. So in our last class, we looked at question number 6, and let me just quickly flash back to topics that we have been able to cover so far. So in our first topic, we'll cover the concept of energy, work, and power. And the second topic, we're able to cover the concept of gravitational field. And the third question takes us to the concept of vector and scalar, and we're able to cover that also. And the sixth question takes us to the concept of circular motion, and we have been able to cover that also. That is close to like 4 topics now that we have been able to cover. And we are going to the next question now. I think the next question should be question number 7. So question number 6 is what took us to circular motion. So question number 7 now. So what do we have there? So for question number 7, we have that if it takes an object 3 seconds to fall freely to the ground from a certain height, what is the distance covered by the object? Take g as 10 meters per second square. Now, if you look at this question, you can categorize it into 2 categories. You can say it is a question under motion, and you can also say it's a question under projectile. Is that taken on? So when you say motion due to gravity, you can relate the question to this, and we can also relate it to question under projectile. So what's the best way to take care of this, so that we're not going to have repetition as we go along with the class? So let's just teach let's treat the concept of motion completely. When I say we should treat the concept of motion completely, I want us to look at it in details in line with projectile motion. So we are going to be covering 2 things in tonight's class. We are going to cover the aspect of motion, that is the topic motion itself, and we'll cover it alongside with projectile motion. So let's see how far we can go with that. Now, when you say motion, what exactly do examiner want to know under this particular topic? Examiner want to test you if you know the definition of emotion. That is, you can tell definition, you can tell when emotion occur, and two, the types of motion, three, the causes of motion, and four, you can carry out some calculation under linear motion. So let's tackle this first. Then when we are done with this, we look at projector. Is that taken out? All right. So when you say motion, what exactly do we call motion? If you check your textbooks, you have the definition of motion to be something like the change in position of an object in relation to time. The change in position of an object with respect to time. You see, those are the things you are going to find. But there's something that you need to understand about definition of motion. And what's that thing is that there's nothing that is completely at rest, and there's nothing that is completely in motion. Because if your daddy is driving and you are sitting down beside your dad, no matter the speed of the car, to you, your daddy is not moving. But to somebody that is observing from outside, that person will see you moving, would also see your daddy moving. Why is it like that? The reason is because if you want to define the motion of an object, it has to be in relation to a stationary object. Are you getting it now? So that's why we said motion is defined as the change in position of an object, change in position of an object in relation to a stationary object. Now, that means that before you can say an object is in motion, it means that when you compare the position of an object with an object that is static, are you getting this now? There is changes. When there is changes between an object that is moving and the one that is static, then you see motion has taken place. For example, now, you all believe that your house remains in the same position. That is, your house is just fixed. Nothing can take it away from where it is. But for somebody that goes outside the earth and the person is looking down to the earth, the person can see your house moving. The reason why you cannot see your house moving is because you are inside the earth and the earth is moving. Your building is also inside that same earth that is moving. For that reason, it's not appearing like it's moving before you. Just like your daddy does not appear like he was moving when you are both in the car. But to an outsider, your daddy is moving. To you, your daddy is not moving. So for somebody that is on earth, the building is not moving. And for somebody that go outside the earth, the building is moving. So that's what we use to know an object that is in motion and the one that is not in motion. Now, when you now talk about these motions, this change in position can occur in different ways. That is why we have what we call types of motion. And the very first one is what we call translational motion. Translational motion. Or you can call it rectilinear. And the second one is rotational motion. Rotational motion. The fourth one, sorry, the third one, random motion. And then the fourth one is going to be oscillatory, or you can call it vibratory motion. This thing appears so simple. Of course it is. But it's for you to understand its application. When you understand its application, all questions underneath will become something cheap and simple for you. Now, let's come to realize, when I say translational motion, what do they mean? You see, this word rectilinear does not necessarily mean that it should be on a straight line. I'm getting this now. When I say a motion is a rectilinear motion, it is a motion that moves in a specified direction. A motion that when you say go to the left, it goes to the left. When you direct it to the right, it goes to the right. It's just like you as a person. I told you that mute your mic, and you mute the mic. You are going in the what? In the direction of where I asked you to go. Are you getting this now? So if we are to relate that to motion, it's going to be what? A translational motion. So when an object, when you see that an object always moves in a specified direction, that is, anywhere they direct the object to go, that's where it's going to go. Such type of motion, you call it what? Rectilinear. Or you call it translational. Are we making sense now?
Yes, sir.
Now, let me show you. A lot of people always think that it is a motion on a straight line. No. It is a motion in a specified direction. So, let me say I have a point A here, and then I have a point B here. And you move from, I said, oh yeah, you are in point A. I get me now? I assume that you are in point A. Sorry, I'm trying to check something. Okay. All right, people are still mistaking today's class. Today's every Tuesday is chemistry. It's Thursday that is, sorry, every Tuesday is physics. It's on Thursday that is for chemistry, and Saturday is for biology and mathematics. Is that taken now? So let's get it clear now. So Tuesday is for physics, Thursday chemistry, Saturday mathematics and biology. And we are looking at a situation whereby we are going to be having chemistry twice in a week. So we are still considering that. So we are looking at Friday if possible, but I'll communicate that to you guys once I'm able to reach a conclusion with the teacher in charge. That's taken now. So let's move on. Now let's say you are in point A. This is you. And I say go to point B. In this case, you are going to move on a straight line. Well, let's take for instance that this is point A, and you have point B here. You know, by the time you move from here, you come down to this place. You know, your movement is not straight because I assume that this place is like a barrier. I know you are considering that you can just move straight like this. No, but I'm taking this place as a barrier for you. So you cannot pass through this place because of this. So you turn like this and get to what? B. You know, your movement is not straight, but you still go in the direction of what? B. Because that's where you are directed to go. Your motion is still rectilinear. So when we talk about examples of rectilinear motion, we said the movement of a man. We said the movement of a man. We said the movement of a car from point A to point B. The movement of the wheel of a car. Wheel of a car. When I say wheel of a car or bicycle or anything, when you steer to the right, the wheel will go to the right. When you steer to the left, the wheel will go to the left. Are you getting this now? So that's why we say the wheel of a car is also obeying what? Translational motion. A car that you want to move from Lagos to Enugu will go in that same direction. The movement of a man, when I say somebody is a man, it means the person is still in control of his sense, either male or female. So if you are still in control of your sense, you've not run mad. Are you getting it now? So if they ask you to go to A, you don't go elsewhere. You go in that same direction, irrespective of what the tediosity might be. Are you getting it now? You are going in that what? Expected direction. Therefore, your motion is rectilinear. So whenever you want to know if a motion is rectilinear, you consider the behavior of that thing. Is he always in a specified direction? If yes, then you consider it as what? As a translational motion. You understand that? Okay. I know some people who want to take this class like is motion. I know it. There's nothing I don't know in it. Please pay attention. There's a lot you don't know in it. Okay, so we'll go to the next one now, which is rotational motion. So when you say a motion is rotational, you are talking about what? A body that is moving in a rotating manner about a fixed point. That body is moving, is rotating about a fixed point. So anybody that you have that they have a reference point that they are circulating, that they are moving around it, such body is performing a rotational motion. For example, your ceiling fan. Are you getting it now? So your ceiling fan blade performing what? A rotational motion. Of a car is performing what? A rotational motion. The wheel of a car is also performing what? A rotational motion. Am I making sense now? Now, okay, we also have some other example like the planets. The planets around the sun. Planets around the sun. They are also performing a rotational motion. So, if you look at the wheel of a car, we cited this as an example for translational motion, isn't it? That's to tell you that there are some objects that perform dual motion. Performing a dual motion, we said that object is what? Is having a mixed motion. Because wheel of a car, for example, is an example of a mixed motion. Because it's performing rotational motion and translational motion simultaneously. Am I making sense now? So, but Jamb will not give you the option of what? Mixed motion. Because it's not part of the type of motion in our curriculum. Are you getting this now? So it's not part of the type of motion in our curriculum. But you just have to know that it exists. So if they want to ask you question under mixed motion, they will list out those type of motion for you. For example, they can give you the question like, the wheel of a car is performing which of the following types of motions? You see them pairing it. You can say A, random, and rotational. Random and rotational. You can see random and oscillatory. You can see rotational and translation. Either they use translational or they use what? Rectilinear. And D, you can see something like maybe rotational. Sorry, I'm mixing the option well. You can see something like translational and oscillatory. Am I making sense now? So instead of Jamb to call it mixed motion, they will list out those type of motions for you. So you are the one to know that it's performing what? Rotational and translational. That's that for rotational motion. So the next one is random motion. So when you talk about random motion, you're talking about a motion in an haphazard manner. When I say a motion is in an haphazard manner, is in what? Irregular manner. The manner that you cannot really tell that this will be its next direction. When something is irregular, they call it a random motion. Just like the guys that play PS. If you want to choose a random club for each other, you just click on the box button. When you click on the box button, you can just select any team for you. You yourself don't know the team that is going to select for you. That's random. When something is random, everybody has equal chance. You don't know what is going to be. So, example of such motion include the movement of gas particle. The movement of gas particle. The movement of smoke from a burning bush. Smoke from a burning bush. Okay, who can help us with other example for this? Random motion, anybody?
Steam.
Is that what?
Steam.
Sir, the movement of a fly.
Okay, the movement of a fly or butterfly. Okay, thank you. And so on like that. So all of these are examples of random motion. So what you want to look out for from all these type of motion is what? Ability to identify what makes them look like a particular style, a particular type, my bad. Are you getting it now? So the next one is going to be oscillatory. Oscillatory motion. When we say oscillatory motion, we talk about the to and fro movement of an object. The to and fro movement of object about a fixed point or axis. Figure out now. Please mute your mic. Mute your mic. So we said to and fro movement of an object about a fixed point or axis is referred to as oscillatory motion, or you call it vibratory motion. Now, for you to know objects that perform this kind of a motion, what do you watch out for? You watch out for how they behave. Are they going up and down at a fixed point? Does their direction look as if they are vibrating? And so on like that. So those are the things you need to check. And there is this famous example that Jamb always want to use. And many people don't really know that it's an example of oscillatory motion. Why? Because It looks like rotational. And that's why I said some objects, they perform dual type of motion. For example, if you look at the second hand of your clock, your wall clock or your wristwatch, when you look at that second hand, it's performing dual motion. It's performing a rotational motion in the sense that it's moving around that particular fixed point in a rotating manner. Am I making sense now? And at the same time, it's performing what? An oscillatory motion. I pray that the question we are treating will lead us to simple harmonic motion. Then I will be able to explain how such bodies perform a simple harmonic motion. Or better still, I'm going to link my lecture on simple harmonic motion under this replay of this class, so you can watch everything about simple harmonic motion there, so that you get to understand how the clock perform a simple harmonic motion. It's taking now. All right. So we said the second hand of a clock. The second hand of a clock. Then we have the motion of a talking drum. The motion of the skin of a talking drum. A talking drum. Jamb also like this particular one because only few people understand that a drum is performing what? A vibratory motion, that is oscillatory. The punching bag, motion of a punching bag, also an example of oscillatory. The beeping of the heart, that is heartbeat, is also an example of what? Oscillatory motion, to mention but few. Now that we have understand all the types of motions and their examples, what again do we need to understand? I want you to understand that Jamb at times, they will ask you questions under this motion in another manner to test if you really understand it. Let me give you an example of what I'm trying to say. Jamb can say that if a body, pay attention please, because this class is to tell you and expose you to how tricky Jamb can be in testing your ability or your understanding of a particular concept. Jamb can say if a body moves with a constant speed, a constant speed, the body move with a constant speed, and at the same time, undergoes and at the same time undergoes an acceleration. An acceleration, its motion is said to be A, circular, B, oscillatory, C, linear, D, let me put rotational there. Which of these do you think is the right answer?
C.
Okay, any other opinion?
C. C.
C, right?
Yes, sir.
Yes, sir.
A.
Okay. Who said A?
Me, sir.
Okay, Maria, right?
Yes, sir.
Okay. Now, for those that chose C, were you in class on Saturday?
No, sir. In the night.
Was it in the night? Yes, I think it was in the night.
No, I was not in the night class, sir.
Okay. Yes, that was why. Now, let me answer this question based on, thank you, Maria, for helping us with the right answer. It shows you are in class. So A is the right answer. Please, you can watch the replay of that class so that you understand the concept of circular motion very well. So please, for auxiliary rectilinear rotational, for you to be able to answer any question as a Jambite, even if you don't know that question before, if you don't know the right answer to the question, let's take for instance that you don't know the definition to circular motion, you don't know it, and you are presented with this kind of a problem, how do you analyze it? You already see that if a body moves with a constant speed and at the same time undergoes an acceleration, its motion is said to be, so circular motion you don't know. For auxiliary motion, you were told that it is what? The to and fro movement of an object. Does this one say anything about to and fro movement? No.
No, sir.
Automatically, this cannot be. Rectilinear motion, the motion of an object in a specified direction. Does this one talk about the motion of an object in a specified direction? No, so it cannot be. Rotational motion is the motion of an object in a rotational what? Manner, as this rotating manner about a fixed point. Does it not talk anything about that? No. So that's to tell you that what? It is this one that will be the answer. That is if you don't even know the definition of circular motion. And these are other ways that examiner always use to test what you know. They will ask you what you don't know, and they will put the options that you know, they will put it there. So because you know those options, you know they cannot be the answer. So if you're able to analyze those options that you know, so that one that you don't know will likely be the answer. Since the other ones, like you know what auxiliary means, you know rectilinear, you know rotational, the question is not looking like any of the three, then it's going to be the third one, the fourth one. So please, let's try as much as we can to take note of that. And that's how tricky Jamb can be. Now, having said that, what's the next thing that you need to also understand under this topic after you've been able to define it, you've been able to list the types of motion of it that you have? The next thing that you need to understand about this topic is the equations of motion. That is equation of linear motion. Equation of linear motion. Now, when you talk about equations of linear motion, what are we talking about? We are talking about equation that we can use to predict properties of a particular motion. And let me quickly list out something. When you have a body that is performing a motion, these are the properties that the body can have. The body can have final velocity. The body can have initial velocity. So this one is represented with capital V. This one is represented with U. The body can have acceleration. That's A. The body can have time. That's second. That is T rather. The body can have distance. And that is S. You see these 5 things, they are what we call the properties of a body that is performing a linear motion. So Jamb can ask you to find any of these property by giving you some property to determine that one. For example, in your family, there is somebody that you know that this person, let's take for instance that we are a family. And Maria, for example, she likes to eat rice. Whenever she finish eating, she will drop the plate on the table without taking it to the kitchen. Are you getting it now? Then you will never meet her at home. Let's say those three characteristics is particular to Maria. So I can give you a question and say that, okay, a food was eaten by someone and was kept on the table without wash. Are you getting this now? Find the person. Because I already give you two characteristics of that person. Are you getting this now? With those characteristics, you can determine the person. Because you know that, oh, with these two, this is going to be the person. The same thing goes to all these 5 properties of motion. Examiner can give you the final velocity, the initial velocity. They will ask you to calculate for the acceleration. They can give you time, they will give you distance, they will ask to calculate for acceleration, and so on like that. So how do you calculate? So you must understand the relationship that exists between all these properties. That relationship that exists between all these properties is what we call the equation of motion. And the first one is that V is equal to U plus AT. And the second one is S equal UT plus half AT squared. And the third one is V squared equal U squared plus 2AS. And these are the 3 equations of motion. So you can see in some textbooks, they'll say they have the fourth one, whereby V is equal to the square root of U squared plus 2AS. But I won't advise you to study this kind of a thing. Why? Because it's not helpful. So forget about it. So let's focus on these 3. Now, all these 3 equations, you need to know when to use them and how to use them. When they give you question, the first thing you want to do is to write out the parameters given to you in the question. Maybe you start reading that a body starts from rest and move with a velocity of 20 meters per second. So you write down velocity of 20 meters per second and accelerate 4 meters per second square. Acceleration 4 meters per second square. You see, by the time you are able to write down all of these things, and in time 2 seconds, find, for example, find the initial velocity. Find the initial velocity. So you're looking for U. So this question is not correct though. I just want you to understand how to use all this equation. You see that this one have V, this one have A, this one have T, and you're looking for U. So you scan through your head because all these things are supposed to be in your head. Which of these equation has V, A, U, and T? You get to see that it is equation 1 that have it all. So that tells you that it is equation 1 that you are going to use. So the parameters given to you in a question is what determines the equation to use in solving that question. Now, what are other things you need to know here aside from this? Another thing you need to know is that what are the factors that affect all these properties? For example, when can final velocity be 0? When can initial velocity be 0? When can acceleration be 0? When can time be 0? When can distance be 0? Or when can they be negative? You must know all this also. Let's start from final velocity. What do they call final velocity? Let's say you want to move from point A. This is point A. and here is point B. So if you want to move from point A to point B, you want to move from point A to point B. And then you start your movement and it gets to this place. You stop. Let's say you start with a velocity of 2 meters per second. You now get to this point, you stop. You now start again from here. Maybe you now change your velocity to maybe 1 meter per second, or you increase it to 3 meters per second on getting to this place. Mind you, you did not stop. Note that very well. You did not stop. You are moving from A to B, but immediately you get to this point C, you change your speed to 3 meters per second until you get to B. I'll take it again. You start with 2 meters per second from A and you are going to B. But when you get to C, you change your velocity to 3 meters per second and you maintain it till you get to what? B. This 3 meters per second is called the final velocity. So final velocity simply means the velocity that you maintain to finish the motion. Why this one is going to what? Is going to be your initial velocity, the velocity that you started with before you change. Are you getting it now? But let's now take, for instance, that the body starts from rest. You are going to B, and the body just moves from B and maintain the same velocity, let's say 2 meters per second, until it gets to B. In this case, we said that the body is moving with a uniform acceleration. So if the examiner don't want to say that the body is moving with a uniform acceleration, they can tell you that the body starts from rest. So whenever they tell you that a body starts from rest, what it means is that the initial velocity of the body, is equal to 0. Once you hear that statement, a body starts from rest, don't think twice. Just set your U to become 0. Is that taken now? Now, what happens when initial velocity is greater than the final velocity? Or we have already known when initial velocity can be 0. Is it possible for final velocity to also be 0? Yes. Final velocity can be 0. But what will be the case? The case will be that when the body is retarding, let's say you take your car and you move down to this place. But on getting to this place, you start reversing back to this place. This velocity that is final velocity will become what? 0. So if the final velocity becomes what? 0 when the body changes its direction. When the body changes its direction, what happens? Final velocity will be what? 0. That's when they say when the body is retarding. Retardation is like changing in direction, the reduction in acceleration. When acceleration is no longer positive, that's what we call retardation. In that case, final velocity will be 0. So we need to take note of that. Then the next one, acceleration. When I say acceleration, what acceleration simply means is that the rate at which velocity change. Let's say that a body has an acceleration of 2 meters per second square. And that body has a velocity. Maybe the body starts its motion with a velocity of, let's say, 2 meters per second. For example, I'm trying to work with a very small value. Now, the acceleration is 2 meters per second square, right? And the velocity the body is moving with is 2 meters per second. What this 2 meters per second square means is that the velocity of this body is increasing by 2 every seconds. Let's say this is when the time is equal to 0. So what will happen when the time is 5 seconds? So in the next 1 second, this body will become what? The velocity will become 4 meters per second. That's when the time is 1 second. When the time increased to 2 seconds, the velocity would have increased to what? 6 meters per second. So what happened when the time increased to 3 seconds? The velocity will have increased to what? 8 meters per second. So because why is it increasing by 2 every second? Because the acceleration is 2 meters per second. So if the acceleration is 3 meters per second, it means every second the velocity will be increasing by 3. So when can acceleration be negative? Acceleration will be negative when velocity is decreasing every seconds. Do you understand that now?
Yes, sir.
All right. So the last part of it is where examiner do hide for you, and that's the kind of interview question that I also like giving teachers. If I don't want to stress you and I quickly want to just know how vast you are, how well do you understand phases, I'll come to this case of time. You see, in the question that they told you that time is 3rd seconds, or they say 4th seconds, or they say 5th seconds, or they say what? 2nd seconds, or they say 8 seconds. Whenever you are giving time in this kind of format, this is the position format. Are you getting it now? Please don't make the mistake. Like if they say in the 3rd seconds, don't make the mistake of saying the time is 3 seconds. If they say 4th seconds, don't make the mistake of saying that the time is 4 seconds. What does it mean to give you time in form of position? Let's both consider these questions. Please, I want you to take down this question so that we can look at it together and help you to answer these particular questions correctly. Are we ready, guys?
Yes, sir.
Okay.
Yes.
All right. I want you to take down this question. If a car, please take it down. I might not be able to write it because of time. If a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, stop. The distance it covers in the last 1 second of its motion is, the distance it covers in the last 1 second of its motion is, option A, we have 95 meters. Option B, we have 100 meters. Option C, we have 500 meters. Option D, we have 905 meters. And option E, we have 1000 meters.
Sir, please repeat the question.
Okay, the question states that if a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds, the distance it covers in the last 1 second of its motion is. So I want us to look at this question together. I will now recast the question so that you will understand what I'm about to explain. Now,
B, sir. 100 meters.
okay, that's what you get as your own answer, right?
Yes, sir.
Okay, the question says in the last 1 second. So, okay, so let's solve it together. If a car starts from rest, it means that the initial velocity is what? 0. And moves with a uniform acceleration of 10 meters per second square. Acceleration is 10 meters per second square The distance it covers in the last 1 second of its motion is, okay, sorry, for 10 seconds. Okay, we are given time to be 10 seconds, comma. The distance it covers in the last 1 second of its motion. So we are looking for the distance. Now, the last 1 second of its motion is going to be when?
9.
Within 9 seconds and 10 seconds, isn't it?
Yes, sir.
So we first of all calculate the distance it covers in 10 seconds. We now calculate the distance it covers in 9 seconds. Are you getting this now? We now take the difference between the two. That will give us the right answer to this question. That will let us know the distance it covers in the last 1 second. I believe everybody understands this.
Yes, sir.
Yes,
Now,
sir.
if you look at these parameters given to us, we have U, we have A, we have T, we have S. So if you look at the whole of the equation of motion, you see that S equal UT plus half AT squared is the most suitable formula to use. Abi?
Yes, sir.
So S now equal, if you put 0 here, this one will become 0. So we have 1/2 multiplied by our acceleration is 10, then multiply by our time, which is 10 squared. So this will be 2 here 1, 2 here 5. So you have that S is equal to, this one will give us 100. That'll be 5 times 100, that is 500 meter. I say this now. So we
Yes.
then calculate for when the time is 9 seconds. So we have that S equal 1/2 times 10 times 9 squared. So this will give us 2 here 1, 2 here is what? 5. So you have that S is equal to 5 times 81. What do you likely to have?
405.
405. Thank you. So the distance covered in the last 1 second is going to become what? The distance in 10 seconds minus the distance in 9 seconds. And that will be 500 minus 405. So this will give us what? I think that should be 95 meter. Abi?
Yes, sir.
Option A is the right answer. Now, let's take for instance that examiner don't want to what? They don't want to give you in this format. They want to give you in another way. This same question, they want to give you in another way. Examiner will now say that, examiner will say that if a car starts from rest and moves with a uniform acceleration of 10 meters per second, calculate the distance covered in the 10th seconds. Calculate the distance covered in the 10th second. Can you see that now? You see that I did not mention that in the last 1 second. Am I making sense now?
Yes, sir.
Yes, sir.
So in the 10th seconds means in the last 1 seconds. If the time is 10 seconds, then you just approach it like this. I get this now. But let me give you a very shortcut of doing it. Instead of me doing it separate like this, it will take me more time because I'm jammed by it. I can just do it like this. I can just say the distance in the 10 seconds is going to be S equal UT plus half AT squared. And since U is 0, I will have that S equal 1/2 times my acceleration is 10, then multiply by the time. I will now say 10 square minus 9 square. So this will now be S equal to here 1, 2 here 5. So that will be 5 multiplied by 10 square is 100. That will be 100 minus 81. And I will have that S is equal to, that should give us 19. That will be 5 multiplied by 19. And that will give us 95 meter. You see, this is very short than this.
Sir, what of if the time is in 10 seconds and he said find it in the second seconds? How will you do it?
Find what? I don't get that question right.
Like, let us say the time is 10 seconds. Then I said, look for it in the second seconds.
Okay, like in the last two, they will not say in the second second. They will say in the last 2 seconds. You get,
Okay.
so in the last 2 seconds, so the last 2 seconds simply means within 8 seconds and 10 seconds. So you calculate it using the first method, because the second method will not work for it that way.
Okay, sir. Thank you, sir.
Now I think the second method should also work. Yeah, you just change this one to 8, but there's no way they will want to bring it in form of position that way. So they want to split it out, so you can use the second method also to solve it. Is that taken now? But instead of
Yes, sir.
9, it will just be what? 8.
8. Thank you, sir.
Okay. I believe everybody understand this now, right?
Yes,
Yes,
sir.
sir.
Okay. So
Yes, sir.
that's tricky way of asking you question under this particular topic. Okay, let me see if I can get maybe one question more of this nature. Okay, I think I have one in 1992. 1992, Jamb 1992. So take down, please. A body starts from rest. A body starts from rest and moves with uniform acceleration of 6 meters per second square. What distance does it cover? What distance does it cover in the third seconds? In the third seconds. Question mark. Option A, we have 15 meter. Option B, 18 meter. Option C, 27 meter. Option D, 30 meter. So guys, what's the right answer to that question?
D, 30 meters.
D, 30 meter.
Yes, sir.
Okay. Another person? Another question? Another person? Another response, please.
Sorry, sir. It's supposed to be 15.
Okay. Are you
A.
changing your
I
option?
meant, yes, sir. A.
Okay. Somebody say A. Do we all go with A? Okay, please work it out fast. It's just 1 minute question. Any response aside from the 15 meter? Or do you all agree with the 15 meter so that we can move on? Okay. Let's move on because of time. So 15 meters should be correct. So if you look at the question, they say a body starts from rest. That means that U is equal to 0. and moves with uniform acceleration of 6 meters per second, A is equal to 6 meters per second square, what distance does it covers in the third second? So distance S, and the time is what? The third seconds. So if that should be the case now, you have that S is equal to UT plus half AT square, and this will become S equal, U is 0, so this one will become 0. So that will be 1 over 2 multiplied by A, which is what? 6, then multiply by the time, that will be 3 square minus 2 square. So 2 here 1, 2 here will give us what? 3. So we have that S is equal to 9. That will be 3 into bracket 9 minus 4, and that will be 3 times 5. So we have 15 meter will be the right answer. So do you get that clear now?
Yes, sir.
Okay, so that's a very brilliant one from the person that gave us response to this. Thank you so much. I believe everybody now understand this, Abi.
Yes, sir. So, sir, if time is not given and time position is given, now so use that time position as the time.
I don't understand what we mean by time position.
Like, okay, sir, I understand. Don't worry.
Okay. All right. So now let's move on to the point whereby this becomes you can just log out and off the data. Sorry, please. Okay, so let's move on to the point whereby we want to consider motion under gravity. Motion under gravity. You see, when you say motion under gravity, it's something that we can refer to as projectile in one direction. Are we there now? That is one-dimensional projectile. In this case, we have that, recall that this is equal to U plus AT, S equal UT plus half AT square, and V square equal U square plus 2AS. If you have this is for linear motion. But when it becomes motion under gravity, what will be the difference? The acceleration will become G. Are you there now? So if the body is falling from the top, G will be positive. But if the body is moving upward, G will be what? Negative. So we have that B equal U plus GT. We have that H, because S will now become vertical distance now, which is height. H equal UT plus half GT squared. We have that B squared equal U squared plus 2GH. Are you getting this now? So this will give you the equation for motion under gravity if the body is what? Is going downward. But if the body is going upward, the equation will become V equal U minus GT. H equal UT minus half GT squared. And V square equal U square plus 2GH. So this will be, sorry, minus rather. So this will be for when the body is going upward. So you just, how do you now know if the body is going upward or downward? You just need to pay attention to the question. So let's take some questions under this. Then I will now discuss some special cases of questions under motion or motion under gravity. So let's take some questions to just verify and look into all this equation. All right. I believe it's clear to us, right? Before I claim.
Yes, sir.
Okay.
Yes, sir.
Okay. All right. Okay, so let's take down this question. Try this. Let's try this question here. A palm fruit, a palm fruit, a palm fruit, a palm fruit is dropped. A palm fruit is dropped to the ground from the top of a tree. From the top of a tree, 45-meter tall. Full stop. How long does it take to reach the ground? Take G as 10 meters per second square. So option A, we have 9 seconds. Option B, we have 4.5. Sorry, please, hold on. Hold on, please check outside, something is smelling. Baby, Peter. Option C, check. What is up on that gen? Option C, sorry please for the distraction. Okay, so option C will give us 6 seconds. Option D, 7.5 seconds. Option E, 3 seconds. Now,
3 seconds.
3 seconds.
okay, we'll calculate it. Okay.
3 seconds.
All right, before we go, I want to explain something to us. I love the fact that we are smart about it. You see this kind of a question. When something is dropping from the tree, at this point, final velocity is 0. And at this point, initial velocity is 0. You see, when you throw something upward, when the body gets to the maximum height, final velocity will be 0. When something fall and fall down to the ground, initial velocity will be what? 0. Please always put that at the back of your mind. So if you look at this question now, the what's it called? The palm fruit is coming from the top. So by the time it gets to the ground, initial velocity is what? 0. And you have H to be 45 meters. And you have G to be 10 meters per second square. And you are asked to look for what? Time. So out of the equations, you have V equal U plus GT because it's coming down and it has to be plus. Then you have H equal UT plus half GT square. You have V square equal U square plus 2GH. Which one do you think is relevant to the question?
The second one.
The second one. H is equal to U, U is 0, so this one will be 0. So H will just become 1 over 2 times 10 times T square. That will be what we are looking for. So this H is 45. So 2 here 1, 2 here is 5. So we have 45 equal 5 T square. So divide both sides by 5. T equal to 9. T square equal to 9. So T equal the square root of 9. And that will give us plus or minus 3 seconds. Of course, time cannot be negative. So we pick what? The plus. That's 3 seconds. And everybody is just correct. Do you understand the explanation there now?
Yes, sir.
Yes, sir.
Okay, so let's look at another example under that before I now talk about some technical conditions under this motion under gravity. Okay, this is 1981, Jamb 1981, question number 1. The question says a particle is projected. A particle is projected vertically. It's projected vertically upwards with a velocity of 20 meters per second. What maximum height does it attain? What maximum height does it attain? Take G equal 10 meters per second square. So start your calculation now. Option A, 200 meters. Option B, 2000 meters. Option C, 20 meters.